Welcome back, Generals, to another Let's Fix Generals, a 0 hour to make the best game ever, and we are still working on an unassemblize tool, and we are working on the stack string optimizations. Okay, so we basically we need to search for std string. Yeah, std string. There we go. Good. So let's work our way up. Good. So we have compare no case. String view. String view is fine. Strip string. Apps pass. Okay, so I don't know why there's suddenly these spelling errors highlighted. Can we disable this? Disable spelling errors. Spell. No, nothing found, of course. Oh boy. Visual Studio 2022, disable spell check. Really? It's a reg edit? Are you serious? Disable spell checker. Well, there's no such option here. Ah, here, disable spell checker. Thank you. Wow. Good. It's too much features being added in these IDEs. Why? Spell checker is retarded idea. Absolutely retarded. Good. So, runner options. No. Runner. Get source file. Append to string. PDP reader. Oof, we have an allocation here. Oof. contains a string. There's not much we can do here. Is auto str. This one should be a string view. String view. Get config file name. I think this should also be string view. This as well. Mm-hmm. Oh. Well. Cd string. All right. Okay. Well, this one should also be string view. Okay. Okay, what else? Let's see. I think this looks relatively good. Yeah. Output file. How do we convert it to view? String view. I already forgot. SCD string to string view. Operator. What? How do we use that? Const expert. I don't know what this is. SV. I do wonder, is it enough to maybe just type it like so? No. So we always have to type it like though, like so, string view. No? Maybe we need to create a helper function. Std string view templates string type. Maybe it should be in util. I'm a bit surprised though that there's no native C++ std string to std string view. I mean, okay, that's actually the inverse. There's no one answering this question. Let's go to our friends ChatGPT. What is the best way to convert std string to std string view? Implicit, explicit. Ugh. That's so much writing. But oddly enough, it doesn't even work correctly. Like here, we get an error. Oh, hold on. I see what the problem is. We have to pass a v, that's why. Okay. So basically the problem is that our command line type here, we have an operator here, t, but this one only casts to std string and not to string view, and that's why it errored. So we need to explicitly access .v, and then it works. Okay, my mistake. Input file .v. There we go. Well, then here we could also pass string view. Okay. Well, looks like we need to make a massive pass here over the string view stuff. Well, this can take a while. Okay. Okay, so we have I wanna in the utils we can probably also change this to string view here. This. Right. So we create a UTF-8 std string view. Oh, actually, it should be W string view. And then, does that work? 2 bytes. Oof. Oof. Why does this not work? 2 bytes. What kind of variants are there? First, last. Okay, so maybe we need to pass dot begin and UTF-16 dot end. No. That gives an iterator. Okay, then data and data plus UTF-16 dot size. There we go. Okay. Okay. Then can remove this. UTF-8. There we go. All right. So that means we should be able to delete these two and this one here. And these. And these. Okay, so far so good. Then we can also change this to a string view. String view file name, and this here as well, string view path. There we go. String view. Ta-da, ta-ta, and ta-ta. Okay, good. String view. Okay, we need to std string. Oh, really? String view. Okay, let's see if they're compiled so far. Probably there will be some errors. Yeah. Okay, so str. Huh. Oh. Printf. Okay, so here input type removes this. Input type. .v. .v. This one is a little bit of a problem. Does FMT actually have a native printf? Print line file vprint. Printf with string length. So something with star, right? Here star maxlen string minlen maxlen dot star or just star? Dot star. dot star. Okay. So we put like this, and then we put dot size. Let's do static cast int and str.data. Yeah, it's a bit convoluted, but I think that's fine. Good, let's see if that compiles. Yeah, okay, this does. Good, so we got a bunch of string views, that's nice. Yeah. Okay, let's search for std string reference current projects. Let's see. We can probably also make this here a string view. String view. Ta-da. Hold on. Ta-da. Load. Ta-da, ta-da. Ta-da. Okay. Get file name. I think here we can also just return string view. City string view. Here as well, string view. Okay. Oh. String view. EF stream. Oof. EF stream. Constructor. File name. File name. Oh, it doesn't take a string view. Oof. Oh, that sucks. Well, in that case, we don't use string view here. This one expects a C string. Okay, it looks like we should not switch everything to std string view yet. Yeah. Because there's some API that still relies on std string. Yeah. Okay. Good. Append white space. Okay. Okay, we also don't need to touch this one here, the ASM printer, but the ASM matcher we should probably touch. Let's see. There we have a text split instructions. Text CST. Wow. Let's see. Text CST. Data C. So if we pass a string view here, then we would iterate towards the end and not a null char. C. Index. Yeah. Okay, so if we made this a string view, string view, string view, and so we would have data, and we would have const char end equals text data plus text dot size, right? That's the end, and the end. So if C is not end, yeah, there we go. I think this will work. Then we can also pass string view here. And here. String view. Ta-da. Ta-da. Okay. text. Yeah. Okay, that's nice. Here's a match. Okay, so find content, name empty, find. Okay, this one needs to be a string because it's part of the map key. Okay, here we keep all this. Get source file name. Get source. Key. Okay, let's go to function dot cpp and actually let's see if we see some more append to string. Source file. Yeah, there's some things that we shouldn't use string views for. Yeah. Yeah, string views for everything is also not the answer. Good. So there's probably some things I would like to walk back on. So I think this is fine here, these string views. But main, I think these string views are probably load and process PDB. Load PDB. CSTR. Get file name. Yeah. Okay, so on the PDB reader, yeah, I would like to revert this here. Resets. And resets. I think this here is fine. Yeah, I think this is fine. This is good here. Yeah. Okay, by the way, these guys we can delete here. they are not useful. So we reset this, and we also remove these two here. There we go. Making slow and steady progress. Good. Okay, so then let's get to function.cpp. There's a little bit to do. Function.cpp. Oof. All right. So we're looking at a std string. Here, yeah. Good. Then let's search for all these format strings. There we go. Okay, so we would like to use stack string here. Stack string format. And then we use util assign formats. And then we put formats and this here. There we go. And that should, and then assign string append format. Assign string append. Is there also a different assign string append? Good. Now, a good question is here also, why don't we just append the format here? Which I think is what was originally in the first version of unassemblize, and then we used std format for some reason, fmt format, but I'm not sure why. Maybe we should just pass a format in a native function here. So we don't even use a stack string here. We just pass it here. Or is there any problem with that? I don't know. I don't know what my original motivation was to change it to FMT format. Oh, but we need to change this to percent. Percent s. Percent s. Ah. Because we pass a string view, that's why. I see. Because we pass different types that printf won't be able to use. Okay, let's dial back here again. So here we give a, so here we could use this, but here not, because here we use a string view. I think that's a reason. Yeah. Okay, then. It would be nice if there was a Zion string append string format, just without a format, just append string. Because how about we use percent dot star s, and then we use dot size with integer and dot data. Maybe like that. So we use percent dot star. Oof, this will be a lot of work. Percent x. Oof. This is an unreadable mess here. Yeah. It really is an unreadable mess. This Zion string, can we do anything with it directly? No. It's totally opaque type. Sign this formatter. Science string. Let's ask ChatGPT. What is the best way to append a string to a science string in C++? Science string append. Oh, there is a science string append. Hold on. That would be amazing. Science string append. Well, now the question is, what the hell is that science string view? Oh boy. Well, that doesn't work. That doesn't work. Science string elpos. That's a shame. Let's see, is there any like const char in here? Science string view inside buffer. Returns a view inside a null terminated C-style string. Jesus Christ. Well, it doesn't help. Science string view contains a string. What? The view internally reuses the normal string struct to allow cars without any runtime overhead. What? What is this bullshit? What is this bullshit? This is total bullshit, this thing here. What? This is not a view because it owns a string. It owns an instance. Like, this is not a view. This is absolute garbage design. What are these guys doing? Oh, I see. So they just treat it. Basically, this is nothing other than an alias for Zion string. But it's not the Zion string, but a separate type. Okay, I see. So I did this composition so that they can use this pointer here. Oh my gosh. Okay. I see. Okay, so Zion string append. Yeah, that is yeah. Okay, so we have two. Yeah, yeah. I mean, it is really convoluted way of doing this, but it's probably the most efficient, but it's also the most error prone. Right? If you make a simple mistake here, then this all falls apart. Right? So we really need to concentrate when we do this. So here this would be dot star %x int dot size dot data address do we really want to do this? It's so much more complicated. It's also so much harder to look at. But I suspect it's the fastest because we don't have a middleman. We format directly on append format. The alternative would be to have the stack string format on this guy and then pass the result of the stack string to the append format and then hope that the append format, well, we would then, like, if we do it here, so let's say we do stack string str and formats, right? Formats, and then we do util assign formats, and then we take this guy here, right? And now what we have to do, we would need to comment this out, and then we would do this, and then pass format dot size and format data, essentially. Well, that doesn't make it much easier to read either, right? Because now you have this middleman here. That's also complicated. For I would say we do it on the native, native call. Which is a lot of monkey work now. Okay, so maybe we can do a little bit of copy pasting here. So we got this guy here. Let's copy it in here. And in here. And here. So this is %x, %x. Oh boy. This stuff is unreadable. Okay, so here we got this. So %x and another %x. And here we got another %x and %x. Pin formats, yeah. Okay, here we got some error. Okay. %x, %x. Oh man. Oh. I do wonder, does X take, oh boy, print F X unsigned hexadecimal integer? I think it needs to be XLL, no? XLL. Needs to be XLL. Oh boy. Okay. Okay, XLL, XLL, and oh boy, what is the problem now here? Append formats. Okay, so we got LL, we got size, integer, data, yeah, address, yeah. Good. So okay, so we have symbol name dot size. We cast it to integer, and we do symbol name dot data, and then we copy this guy, and then we paste it here, and here, and here. There. Okay, anywhere else? No. Okay. Then next we will get this stuff here. And we put it here. Prefix sub. And here. Value. Value. Offset. And value. And that's it. Okay. And then we have, oh man, prefix off. So we have this one, prefix of address, and value, and value, and offset, and unc value, and that's it. Okay, so this means we got rid of the allocation here. We got rid of the middleman. And the hope is that this is much more performant. Plus we also pass the size of the string, so it doesn't need to do strlen on this thing, which wouldn't be such a big deal because it's typically short, but a symbol name can be quite long, yeah. So this could be expensive if it was strlen it. strlen. Okay, so offset value. All right. Good. So we processed all these guys, which was a lot. It does compile. Now the question is, does it also run? Let's see. Compare. All right. Weapon. Unrecognized opcode. Okay, so we made a massive mistake here. An absolute massive mistake. Wow. Well, that's rough. That's extremely rough. Yeah. Now I would say let's put a breakpoint here and see if one of these gets hit. No. Okay, now the question is, where's this error coming from? It's not even calling here into these functions. Oof. Jesus Christ. Okay, how do we find the problem? So wow, performance is super bad. Because it just lists a whole lot of file things here. Okay. Yeah, okay, so we totally broke it. Yeah, that's what I can already say. I'm a bit confused why it doesn't hit our breakpoints here. It should have. Maybe it's going wrong somewhere before already. Oh boy. Okay, what did we touch? Function. String. So let's put a breakpoint in here. Good, so it does enter here. Instruction. Instruction buffer. Oh, our instruction buffer has 0 size. Yeah, well, that's not smart. Instruction buffer. Let's see. Instruction buffer. Yeah. Okay. So we should probably resize instruction buffer dot capacity. I think that is the main problem here. And I suspect this one will make it 1022, essentially. Well, why is it stalling now? So instruction buffer. Yeah, 1022. Okay, so I suspect that this will work now, and then we can put we have a breakpoints there, and now it gets on here. That's good. And now we go in here, and we will have string hit here. So can we see a string vector? Well, let's hope it went well. Okay, we get some result now. Yeah, yeah. Okay, good. Okay. So this is now formatted on the stack, which should be pretty good. Yeah. Okay, there's no middleman. This is formatting right onto our buffer, hopefully. Maybe. Maybe not. Good. Then I guess this will be pretty fast. Yeah. Okay. Yeah, this looks as usual. Okay. Yeah, we can review it again if we made no mistake there. Buffer. Instruction buffer. This is resize. I wonder, do we really need the stack string? Maybe we could also instruction buffer. What if we just put a guess it's fine. It probably could also be a small vector, stack vector. Hmm. We can also put stack w string, basic string w char t. Okay. Good. What other? What we need to really review it well once we have everything fixed or improved. It's easy to make mistakes here. Okay, so std string. Let's check in here. So we have this checksum thing. Yeah, I think this doesn't matter. Section, create section string. What is this? Name. This is also an allocation. How about we make this a stack string? Create time string. Okay, but these can be really small ones. How about in our let's go to stacks. Ugh. Let's go to comment types. How about we do a template? type name, string, no, size t, n equals 1024. Then we put n here, n. Okay. And then we create here stack string. And here we can use a shorter one. So this is, yeah, probably 32. Stack string 32. Okay, so put stack string here, str, then we do str equals that. And here we do util assign format str wait, it just assigns a number? Right, okay. Okay. Return str. Then we do the same here. Str, return str. Return str. Let's do str dot data str dot capacity. Actually, let's do if not invalid time points. What does str of time return? Std. Return the number of bytes written into the character array pointed to by str, not including on success. If count was reached before the entire string could be stored, 0 is returned. 0 is returned, okay. So let's do str dot resize str dot capacity and str dot data str dot size and str dot resize size t written const written resize written. There we go. Return str. Okay, I hope this is correct. We should probably put a breakpoint here. Check it. Okay, and so this guy is now here. So we just say auto section text unformatted text string. I hope it. Yeah, I don't know if it string view accepts this one. Maybe. Create time string dot cstr. Yeah, this is fair. Okay, so it's on the stack and it's pretty fast. Before it was allocation here. Yeah. Okay, cool. Let's see if that compiles. Oh, we got a bunch of errors down here. Oof. Use of request templateless. Okay. So we cannot do this. Oh. Oh. Huh. I guess we would have to write it like so, right? Then it would be, yeah. Oof. How about we do how about we do I don't know if that will work. Probably doesn't. My suspicion is that this won't work. Can we specialize it maybe? So we say template empty. Would that work? No. No, no. Well, stack string. So essentially, so either you write them like this, or it looks a bit unholy, doesn't it? Yeah, it looks a bit unholy. We could have two different names. Could say stack string n stack string t n stack string. Yeah, so maybe we just create like this and we make it n stack string n, and then the default one is the one with 1024, like this, and then here we remove this. Yeah, could do it like that. Yeah. Okay, let's see if that works. I think it doesn't because of this. And well, that also looks a bit unholy, doesn't it? Stack string n. Yeah. Okay, but it compiles, so that's good. Good. What other std strings do we have here? Okay, here we have another allocation that can also be fixed. 26. So this one can be descriptor ID. SD, no, stack string n32, title util assign format, and ta-da. Okay. Okay. Oops. There we go. Title Create descriptor name. Oh, here we can also use text strings. Here, yeah, probably. Because all of these are allocations, every frame. Yeah. Oof. Text string. Descriptor name. Yeah. Okay. How about we continue with this next session? So there's a lot of stuff we can do here. We can remove a lot of allocations. Yeah, all this stuff. It's a lot of small strings. Yeah. Okay. Yeah, we made slow progress again. This is we should have started this effort earlier, because then doing it retroactively is quite a bit of work. Yeah, okay. Then yeah, I will take a break here. Then I wish you a great day or night. Until next time. Goodbye.